I'm going to start with the dog class that this chapter uses as the example, listing 5.1, and then kind of jump all over the place within this chapter. So up until now, we've named our classes kind of arbitrary names. All of our programs have had a single file, single Java file. Therefore, they have had a single class. Some kind of statistics. All Java programs must have at least one class. All Java programs must have one main method, at least one main method. One main method gets called. Not every class needs to have a main method, though every class can have a main method. Sometimes classes have main methods that are used to test them. But only if you have a bunch of classes that all have main methods, only one main method will get used as the entry point to your program. And the way Dr. Java figures that out is whatever file is open on the screen, if you click, when you click compile, it compiles everything that you have open. When you click run, it picks the file that you have visible in the editor window at the time, looks for a main method there. If a main method doesn't exist there, it complains. So even if you click compile when you're in some other class, make sure you go back to the main part of your program before you click run. Otherwise, you get some cryptic error. That's what that cryptic error means. And in general, we've typed public class and then some name that made sense in terms of what our program was doing. So, fun with methods. In the past, we used things like hello world and first program. Things that are more on the active end of the spectrum. But we've mentioned that objects and classes represent things. First program is not really a thing. Hello world is not really a thing. Fun with methods is not really a thing. Sometimes that's okay for the class that contains our main method. I've also seen conventions where the class that contains the main method is called main. Other languages use things like program to name the class that contains the main method. In general, our classes, the vast majority of our classes, refer specifically to things. They don't refer to the act of doing something. They refer to chairs and dogs and screens and towers and keyboards.
So what if you just got class and not public?
We're not going to worry about public and private for now. We talk about those in, I think, the next chapter. Nope. We talk about them toward the end of this class. So, for now, don't worry about the public. It is important. But the most important keyword here is class. This says, I am declaring a new class, and I am giving it a name that, for now, right now, is going to be dog. A dog is a thing. I guess we could also use names like thing that barks, animal. Not as good class names are things like run program. I'm so used to writing good class names, I can't think of bad class names. Things that sound active are bad. Right. It's not. A class name should not be something that describes what the program does. It should describe what real-world object this class represents. So here I'm representing a dog. In the other class, one of the examples very early on in the book, as a Java refresher, was throttle, like you'd find in an airplane. It's a thing that has attributes and operations. In general, your methods are a better candidate for active sounding things, like adjust. In the case of dog, we're going to have write output and get age in human years. Whereas things that are nouns, that's a good way to think of it. Nouns are good for class names. Verbs are better for method names. So, again, go with the simplest possible thing we could write. This is a complete Java class that does absolutely nothing. Not very accurate description of a dog. So, what do dogs have? Dogs have a name, a breed, and an age. Those are some attributes, which we'll also use the term properties to describe. In Java implementation, they become something called instance variables. And for now, don't worry about the name public or the keyword public. We'll talk about that later. If you're following along, this is on page 266. So that covers the attributes, the kind of passive parts of the dog. It has a name, it has a breed, it has an age. Now for the operations. In age, yes. There we go.
So
Yes.
when you have to put a board, why do you use the return at the end? Looking at the 66.
Two different methods. So, and I don't like his style of braces. Yes, Joe.
Why don't you have to write the public static whatever? The public static word name?
Okay, so
Because you can find
I don't actually know where the book talks about this static keyword, but I will talk about it now. Listen. So I've made a big deal about this differentiation between a class and an object. The term static refers to whether or not I need an instance of this class in order to access that method. So something that is static is associated with the class, associated with the definition. So named constants, where there will only ever be one value ever, are associated with the class. So they are generally static. You have public static, double the name and the value. Things that are tied to a particular instance, each individual dog has its own name, its own breed, its own age, are non-static. They don't have the static keyword. There's no corresponding or opposite term for static. It's just static or non-static. If you have static there, it means that it is available without creating any instances of the dog class. And that's one reason that the main method, for instance, is static. It doesn't create an instance of the fun with methods class and then call main on that instance. It just calls main. That method already exists.
So like you were saying earlier, string is like static and the public static thing? Is that what you're saying?
No. So there's no, if you don't have static, you don't have anything in place of static. It is either static or you don't have static. The type pretty much everything requires a type. Methods require a return type. Variables require the type that that value is. So that's what string is here. So it's basically public insert space here where static does not go, then string name. Right, so instance variables and methods do not have the static keyword. Class variables and methods do have the static keyword. So here we're going to create two methods. One has a void return type and is called write output. I'm going to start with that and just copy and paste it a bunch of times because I don't want to end up writing that 5 more times or 4 more times. So the first line is name plus name. And because this is an instance method and the variables that we declared above are instance variables, I have access to them inside of this method. If they had been static, which as far as this goes, it would not have made sense for those variables to be static because they are tied to a specific instance. But if I had static variables, I could access them inside instance methods. Did I say that? If I had static variables, I can access them inside instance methods. If I have instance variables, I cannot access them within static methods because static methods don't have any knowledge of any instance of the class. It's entirely possible that there are no instances of the class. So it's not meaningful to get the value of an instance variable.
So you could put it statically, you could still access this variable.
Yes.
But since you didn't have to have an instance where you have access.
Wait. If I had put static here?
Yeah.
No, I could not access these variables. Because this would be static with no knowledge of any instances. Whereas these are instance variables tied to a specific instance of a dog. In general, static methods should be self-contained. The only things they should operate on are either things they're going to return, things they receive as parameters, or things that they create internally and don't return that are necessary for them to do whatever they're supposed to do. Whereas instance methods, they can access whatever they want inside the class. Breed. Yes, breed. Agger. Years. This is more of that top-down programming stuff. I don't know how I'm going to get the age in human years, but I think it sounds like something good to write a method for, so we'll do that. And then we'll write that method. Methods, just like variables, follow camel case. So the first letter is always lowercase, and the first letter of other words are capitalized, everything else is lowercase. which gets really irritating when you have abbreviations or acronyms inside your method names. For instance, ID is considered to be a single word, so the I is capitalized and the D is lowercase.
So now you're declaring that.
I'm declaring the second method, yes. I put a little bit more white space than the author did, just so it's clear what is what. So this white space and a little bit of style notwithstanding is identical to listing 5.1. This is the implementation of the dog class that the author has. Later on in the chapter, the author talks about there is an easier way to, or in my opinion, more elegant way, and I think in his too, a more elegant way to write this method. But he suggests that every method should only ever have one return statement. And about an hour ago now, I think, I mentioned something called short circuit. I like it. I think it makes for more elegant code. You do have to be careful when you use that. But here in this method, there's a lot of extra stuff that doesn't actually need to be here. Between when we set human age and when we return human age, no matter what code path we take, there is nothing that could possibly happen. Yes? Oh, yes. So that is the error that comes up when you don't have a main in the class. You can't. So this class, you cannot click run and have it run.
But it compiles.
It does compile, yes. And this is. Each class does not have to have a main method. Each class can have a main method. Every Java program that is a collection of classes must have a main method in order to run, but not to compile. So this compiled fine, but if I click run, it says this class does not have a static void main method accepting string angle brackets or square brackets, which is it's true. This class does not have a static void main method. If we want to run this class by itself, we would need to provide a static void main method. In general, it's usually the case that thing classes that represent a specific thing that's used in a larger system, don't have their own main method. That's not the entry point for your system. There's a dedicated class that has a main method, a static void main method accepting string angle brackets, square brackets, sorry. That is the entry point for your program, and everything else is not. Does not have a main method. So we'll get to that in a couple minutes. First, I do want to talk about style. The placement of braces in the book, he places them on the next line. That is my personal style as well. However, it is not the Java convention. What I'm doing here, that is the Java convention. Putting the braces on the same line as whatever gives that block meaning. So here in get age and human years, like I was saying before, there's nothing between setting human age to some value and returning it. So why have that extra stuff? Can't spell. There we go. Why not just return that right there? And at that point, we're no longer using human age. This statement can't possibly execute because we only have two choices for code flow. Either the age is less than or equal to 2, or it is not. So we can get rid of that statement. Oops. And then at that point, human age is no longer being used, so we can get rid of that. If statements, if there is only one statement inside the curly braces, we don't need the curly braces. So we can get rid of these curly braces. And that's probably the simplest formulation of this that is also very readable. If we wanted to go further, we could say that if this condition is true, this thing happens, and the method returns, so we can't possibly get to any of these other statements unless this statement is not true, which basically makes the else useless, superfluous. So we can get rid of the else and unindent this so that it looks reasonable. And that's the fewest lines of code we can write for that method. And if that confuses you, feel free to use more lines of code. Readability is always better than fewer lines of code, because Java is going to compile both of those to exactly the same thing anyway. Java doesn't care. It's really up to you and what allows you to read the code. I look at code like this and can read it fine. I also have a habit of doing this. My business partner can't. It infuriates him. So it's really up to you and the people you're working with. Jill.
I thought you said you only have one return statement.
No. You can have as many return statements as you want. The book recommends that you only have one return statement. The argument that the author makes is that it's more readable that way. And I would agree with him. He mentions if you have a return statement very early on in the method, or very deep inside some complicated logic, don't do that. That's bad. That is very difficult to read. The two situations in which I would recommend having more than one return statement is at the very beginning of the method to do error checking. If, for instance, the post conditions and preconditions that the author talks about later on in this chapter, and also that go into the comments, that now that we've talked about methods, go before your methods. If that precondition is not met, you should check that right up front. First thing you do in your method is check all your preconditions. If your preconditions are not satisfied, immediately return. Don't even bother executing the rest of the method. And the reason for that is if you have one error check, if input is valid, block. Inside of that, you have if other piece of input is valid, and then another block. You can get nested if statements, and it's just unreadable. So it's really balancing how unreadable can I get away with. the other option for having multiple return statements is at the very end of the method. If you have several possible choices, under one condition you want to return one thing, under another condition you want to return another thing, you can do what the author had originally, which is declare a variable right up front to eventually store the return value, go through your conditions, put the value that you will eventually return into that variable, and then the last statement of your method is return whatever is in this variable. The reason a reason I avoid doing that is because if you get into cases where there's more than two situations, especially if you don't have an else, it's possible that you could return a value that is uninitialized. Your variable never gets set to anything that's valid to return, but it will compile fine. However, if there is a code path that does not result in a return statement getting hit, Java will complain not all code paths return a value, I think is the exact error message. And I've seen that multiple times, and it means there is some situation that I have not accounted for. I like that. Personal preference. So questions up to this point. As of right now, what I have on the screen is functionally equivalent to what the author has, even though it's not the exact code. And the reason I want to make sure there aren't any questions at this point is because now I'm going to deviate from what the author's doing. I mentioned that the class for problem 9 of the midterm exam should not take input or create any output, keyboard input or screen output. So no system.out.println statements, no scanner system.in, none of that. That's a good convention to stick to, but sometimes we do want to print out the internal state of a class, and we don't want to go through all of its methods and say, system.out.println, mydog.name, system.out.println, mydog.breed. It would be really convenient if we could say system.out.println, mydog, and have it print out everything that pertains to that particular dog. And to motivate that, let's actually create a save that. Create a new class called dogmain. And this class it's the only thing it will have is a main method. So this will look kind of like every other program we've written so far. So let's create a new dog. Dog. I like some of his examples. Anybody know if Scooby-Doo is on Netflix? Every time I check, it's not, but that could have changed. I have the streaming thing. I gave up on actual DVDs a while ago. It wasn't worth it. Apparently he's 42. I'm assuming that's a comment on how old the show is. So that's my main method. I'm going to create a new dog, store it in a variable called Scooby, set the name, the age, and the breed, and that's what this dot syntax means. The left side of the dot is an object, the right side of the dot is a member or instance variable or instance method. And it's just like assigning any other variable. There's the variable on the left-hand side, the assignment operator, and then the value to stick in there. So I'm giving this.
It's just like you want us to do it.
Right. So for problem 9 on the midterm, you will have a class called polynomial, or no, quadratic, which is like the dog in this example. You will also, during the course of that, have to create some other class to do what I'm doing here in dog main that I don't actually need to see. I don't want to see what your main method looks like. You had a question?
Is this self-standing, or are you referencing the class that you made earlier?
Yes. So this makes use of dog.java. Right now, I don't have to specify, hey, I'm going to use that other class over there. Since they are sitting right next to each other in the same directory, and also in part because Dr. Java has both of them open, Dr. Java can figure out, since I make reference to something called dog, and I have something called dog open, it compiles both of them, links them together, and uses the dog that I've written.
Integrated the new object.
Correct. Yes. So compile, and now, even though I have a main method that uses dog, if I have dog.java selected and I click run, it still complains that this class does not have a static void main method. I have to actually have this class that does have a main method in it selected, click run, and then it runs. And since we call the write output method, we have this this output gets printed out. However, a couple minutes ago, I mentioned that it would be really, really cool. Let's comment that out. If instead of having to remember what I actually called the method that prints out some details about this dog, if I could just do system.out.print ln Scooby, and have Java figure out what it should print out in order to describe this, whatever I'm passing into. And it turns out that Java does automatically provide some way for this to work, but it's not very descriptive. It tells us that it's a dog, and then it gives us some gibberish. Technically, that is the reference. So Scooby is a variable of a reference type, and Java is telling us this is where, more or less in memory, this is where this dog resides. That's really not what we were interested in. This is never, ever, ever helpful. I shouldn't say that. If you're trying to see if two things point to the same object, you can print out their references and see if they're the same. That's about the only case where it's helpful. Most of the time, not helpful at all. However, it turns out that there is a method, a class instance method. Wow, that was confusing. An instance method that you can define that Java will call when you try to print out an object. And Java, in order to do this sort of thing, Java automatically provides, bless you, automatically provides an implementation of this method that doesn't really do anything helpful, because it really doesn't know any of the details of your object. But if you, wrong class, if you define your own, Java will use that one. So I'm going to change the write output method, and then we'll see how this works. The name that, and these details need to be exact. If the method doesn't follow these rules, Java won't use it the way we want it to. The method is called toString. That is lowercase to, capital S, and then lowercase everything else. That's the first thing we need to do. We need to have a method called toString. The second thing we need to do is this toString method does not take any arguments, does not have any parameters. So in this case, we don't have to do anything. Third thing, it returns a string. So we need to change the return type here. Fourth thing, this is not a rule. This is more of a convention. This is the way Java is expecting everything to work. This method should not itself print anything out. So all of the system.out.printlns need to go away. The idea is that whatever the string is that gets returned contains the description of this class. So everything that we have in system.out.println, we need to put that all into a string, and that's what we'll return. So we'll start out with string, too many letters, string description, and wow, equals, empty string. We'll start out with that. And here we will append all of this stuff to that string. Java doesn't automatically give us line breaks, so if we want line breaks, we have to put them in there ourselves.
It seems easy, but
Except the way we had it is not the way that the Java convention goes. And so there are good reasons for not using system.out.println. We won't see any in this class, but there are cases where either your program doesn't have access to system.out, it's not, just don't do it, it doesn't go somewhere sensible. Or when let's say I want to print out the inner contents of an object for logging purposes. In that case, I don't want it to go to the screen. I want it to go to maybe a file or something like that. So I would want to get the description as a string and send it to the file. I don't want the class to assume that I want it to go to the screen and print it out to the screen. So there are several good reasons for doing this. But for now, the main one is that that's the way the Java convention works. I find that this is extremely helpful for debugging, even if I don't expect I would ever want to say in a real running program print out the inner contents of an object. I still write a toString method on the object. That way, as I'm debugging the program, if I encounter a situation where something's not happening when I think it should, I can just print out an object, and because I've already written the toString method, I don't have to worry about it giving me some nonsense. it'll show me exactly what the state of that object is, and then I can see if there's something that's not what I was expecting it to be. We'll just take that one out because it's not doing anything. So, and of course we have to return this string. So we will return description. Now compile everything. Go back to dog main, and now instead of it went away, but instead of printing out gibberish, it'll actually implicitly call that toString method, and that's what it will print out because I have system.out.println here. So let's run, and there we go. We get the description of Scoop. Questions? Yes. Mm-hmm. So at this point, I'm going to remind you of something that I mentioned very early on in the semester, but now that we're dealing with multiple classes, it becomes, well, it comes up again. It doesn't become more important. It's still extremely important and extremely irritating. Every class must be in a file that has the same name as the name of the class. There are no exceptions to that. Java is very unforgiving on that point. You can't put two classes in the same file. It doesn't work. So if you want to create a class called cat, you need to have a file called cat.java. You can't put cat and dog in the same class and call it animals.java. Doesn't work that way. Which I think a bunch of you have come across that issue. If you start writing a class, you save it, Dr. Java automatically gives it a name, then you change the name of the class and try to compile it again. That doesn't work. So let's see. Let's make sure see what we've gone through and what we haven't. Instance variables, we talked about that. Methods, we talked about that. Void methods, we talked about that. Methods that return a value, talked about that. The keyword this. We have not talked about the keyword this. When it comes to instance methods, if we want to refer to the specific instance that this method is being called on, we have a keyword available to us called this, which represents that instance. That way we don't have to, say, have the calling context pass in the current instance. Obviously we have access to all of the instance variables kind of implicitly. We don't have to do anything special. But let's say we created a method called Boolean. This will return true or false. Is older than. And we give it, this method takes a parameter. It is an integer parameter and it is called age. We have an instance variable that is also called age. This is one of the exceptions I talked about earlier at the beginning of class, where you can have two variables name the same thing and it doesn't, there's no problem. In this case, we can say if this dot age, which refers to the instance variable called age, is greater than age, return true. Otherwise, return false. We could also just say return, in parentheses, this dot age greater than age. Do it in one line. Granted, this syntax, using the same variable name, can be confusing. However, this comes up when you're using JavaDoc. So the Java API documentation uses the names of the variables as part of the documentation. So sometimes, since people are going to see the external interface of your class, and you might want to have descriptive names for the parameters, like you're passing in an age here. I'm expecting an age, so name the variable age. It's a lot easier for you to do some workarounds to make everything work using this .age and comparing it to a local variable called age than expecting someone to understand the variable name age to compare my age to. It's long and unwieldy and leaves room for confusion. So that's where this keyword comes in. We have 12 minutes left. Local variables talked about that. Blocks talked about that. Parameters are primitive type, yes. Information hiding. That's this black box concept. There is a method that I assume does something. I don't care how it does it. I just expect that it does what I want it to do. I'll often call it separation of responsibilities. This method does one thing. The method that I'm in does something else. The method that I'm in shouldn't really care how this other method operates as long as it does what it says it's going to do. And that's where that documentation, like the comments that are in the syllabus, which for programming assignment 4 and moving forward are necessary on each method. Preconditions, postconditions, and a description of what the method does. Basically, so that there's some trust established. The comments on the method say that it does some set of operations. Therefore, I expect that it should do some set of operations. Public and private modifiers. The public means that whatever is being modified is visible outside of the class. Private means that whatever is being modified is only accessible inside the class, is not accessible outside the class. So in this instance, right now we have public instance variables. This is bad. This is generally considered bad programming because we have no control over how other people can, or other classes, other pieces of code can change these variables. For instance, there's nothing to prevent anything from setting age to a negative number. Now, how does that make sense? So the way to get around this is using accessors and mutators. We change all of these to private so that there's no way that anything can change these variables without going through these accessors and mutators. And they are tedious, so I'm only going to implement one for age, since that's the example I used. Basically, we have two methods. One that is the accessor, and it's named get, and then the name of the variable. And another one that is the mutator, called set, and the name of the variable. These are public methods. The accessor returns, its return type is the same as the property. So int get age. Proper camel casing. Doesn't take any parameters. And all it does, in this case, is return age. Mutators are void. They don't return anything. They take a parameter that is the same type as the type of the property. So you can say something like new age. And here we're going to test that condition. If new age is greater than 0, no, new age is less than 0. No, hang on. If new age Is 0 a valid age? I think 0 is a valid age. If new age is greater than or equal to 0, age equals new age. Otherwise, we don't care. We don't do anything. So we specify a this mutator method. Now here, that won't work, and that won't work because I haven't specified the. Look, those two won't work because those variables are now private, but I also haven't specified accessors and mutators. So in order to set the age, I can't directly set the age variable. I have to actually call this mutator. So set age, and I call it on 42.
And since you're setting the age, the name, the dog name, goes back to the dog.java, so that's that name is 42 and then the rest of the code.
So this will end up calling set age in dog.java, which is here. It'll dump 42 into the variable new age. It'll test, right? It's greater than or equal to 0, and then it'll set age, this private instance variable, to new age. You can read about methods calling methods. I think I demonstrated that in Fun with Methods as well. Encapsulation is more of this information hiding, separation of responsibilities, the idea that a thing should represent that thing in its entirety. Do everything pertaining to that thing, and I shouldn't have to worry about how that thing does its stuff. I shouldn't have to worry about how a dog prints itself out. This class should do it. It should be encapsulated away. I don't care. In section 5.3 on page 327, defining an equals method for a class. This is something similar to the toString method. There's something that Java provides for you, but it's not very helpful. Don't even bother using it. It doesn't do anything like you would want it to do. You can, however, define your own equals method, and that is a method with the name equals. It returns a Boolean. It takes a its parameter is something of type object, and it's your responsibility to figure out how you're going to compare that object type. You can read more about the details in the book. I think everything else is pretty much something that we've talked about. So, in the last 5 minutes, are there any questions on question 9 on the midterm after this discussion? I think I've covered all the material that's necessary to answer that question. I mentioned don't worry about constructor, implement those as mutators and accessors. We just talked about them. A method to compute the root of the equation, that is an instance method. Does not take any parameters because everything you have is already part of the state of the object. Returns a double. A Boolean method called has real roots, so it returns a Boolean. Also does not take any parameters because everything that's necessary to determine that is part of the state of the object. Solve method, that takes an argument. It is the x value to evaluate the equation. Returns the corresponding y value, so it returns a double as well. You get to choose four quadratics. They don't have to have real roots. In fact, it's the output's a little bit more interesting if you do use some quadratics that don't have real roots and some quadratics that do have real roots. Use the solve method with x equals 5 and get the y value. Again, I don't need to see what main method you use to test the quadratic class. I'm only interested in the implementation of the quadratic class and the quadratics that you give it and the output. And if you have questions on that, I will answer questions by email up until it's due and I'm awake. I definitely recommend looking at this and determining if you have any questions sooner rather than later. Hopefully this won't take a whole lot of time, but it also shouldn't be, trivial.